Today we're going to talk about fermented vegetables, the process and food safety parameters necessary. Specifically, we're going to focus on sauerkraut and vinegar production, and maybe fermented produce would have been more accurate. But this training is a kind of booster. It's designed for extension educators to give just a little bit more background on the food science of some fermented foods. Fermentation has gone on for a long time. It is one of the earliest forms of food preservation. In this graphic, you can see wine production, which is one of the earliest fermented foods. And you might ask yourself, why did all of these different fermented food products across cultures develop? What is the point of this process? We might think of three main reasons that this happened. First, fermentation contributes to food safety, especially in products stored for extended periods of time. Fermented vegetables are often salted, which can limit the growth of pathogens. The fermentation cultures often produce acid, which also limits the growth of pathogens. And high levels of the fermentation cultures, sometimes called starter culture, can impede pathogen growth because the different microbes compete for food to grow. A second benefit of fermentation is preservation. Through these same mechanisms, the fermentation process also slows microbial spoilage. And finally, the third reason is that a lot of fermented foods have a flavor or a sensory profile that people find desirable, so they're tasty products. In a really big picture perspective, we can define fermentation as the process where quote unquote good microbes, the starter cultures, eat or break down components of the food ingredients, things like carbohydrates and proteins and lipids, the same things that we eat. And then the microbes poop out different compounds that have preservative or sensory properties, things like acids or alcohols, flavor intensive molecules, and gas like carbon dioxide. These products the microbes poop out give fermented foods their characteristic elements. So gas production, so carbon dioxide production, helps to carbonate beer and it makes bread rise. Acid production is how we get vinegar, which is acetic acid. When we ferment milk or vegetables, we often get lactic acid produced by the fermentative cultures, and it turns those products into yogurt and sauerkraut. Alcohol production characterizes wine and beer as well as spirits. For liqueurs, an additional distillation step follows fermentation, which is how we get a higher concentration of alcohol. And flavor development is an important component too. Many fermented foods have strong characterizing flavors. Moreover, sometimes you might have the same microbe growing in a product without meaning to produce a fermented food, and we would call it spoiled. You can think of juice you might leave in your refrigerator too long that becomes cloudy and the container swells. Sometimes people say that fermentation is like intentional spoilage. Other people will say that one man's fermented is another man's spoiled, which is all to say, not everyone likes fermented foods because of their strong flavor profiles. There are many different kinds of fermented vegetables the world over. This includes soy sauce, some hot sauces, olives, kimchi, and sauerkraut, to just name a few. This area is also growing in popularity. Here I have some pictures of some novel products like apple cider vinegar pills and kombucha and pickle juice shots, but these are really only just a few. And if you start looking for them in your grocery store, you'll notice that there are fermented vegetable products everywhere. There's a difference between pickling vegetables and fermenting them, which I think, especially for those who teach canning and home preservation classes, home food preservation classes, this is a useful distinction. When we pickle a vegetable, we add the acid in the form of vinegar. So we can produce, these are often called quick process pickles, and we produce them much more quickly. When we ferment a vegetable, the fermentative bacteria produce the acid, as well as additional flavor compounds. So in both cases, the acid is essential to preservation, but the resulting products differ substantially in how they are produced and their sensory attributes. So, looking forward, some key food safety considerations in fermented foods include the production of acid. So, preservation is a consequence of the acidification due to microbial growth. Food safety is based on, number one, preventing contamination from foodborne pathogens in the first place and preventing their outgrowth through formulation strategies. So that could include the addition of salt in something like sauerkraut or the addition of starter cultures themselves in something like vinegar. So let's start with sauerkraut as an example first. Through each of the steps in terms of how you would make sauerkraut. So the first step is to cut the cabbage up into relatively fine pieces. The goal here is to really damage the cabbage leaves here, but you'll want to instruct clients to be careful when they're handling sharp knives and doing this work. You want to wound the cabbage to draw out moisture. So chopping the cabbage into fine pieces is the first. To further draw out moisture and bruise the cabbage, there are tools that can be used to pound and crush the cabbage to extract even more liquid. The goal here is to have a salt brine in the end that will cover the surface of the cabbage. If even after all of this work you find you don't have enough salt brine, your recipe, which will be found on the Ohio Line fact sheet page, will also instruct you that you can create more brine with just salt and water that you bring to a boil and then cool before adding to your mixture. You then add salt to the cabbage. The recipes found from the National Center for Home Food Preservation and on our fact sheets give the exact ratio to use. So this amount of cabbage with this amount of salt. But that ratio has been optimized to both inhibit pathogen growth and select for the growth of the fermentative microorganisms. And so this is why we noted earlier that the salt level is one of the key ways that we protect food safety in fermented vegetables like sauerkraut. The next thing that you're going to do is pack the cabbage to store it during the fermentation. This method is something that you can implement in a classroom setting. So here you could pack the cabbage pieces into Ziploc bags covered with brine, fill as tightly as possible, and seal after pressing out the air. So this is something that you can send people home with to monitor their own fermentations. Traditionally, people will put their cabbage instead into some sort of fermentation crock, where the cabbage is submerged below the level of the salt brine inside the crock. The container should be made of glass, crock, or food-grade plastic, but not metal, to prevent leaching of heavy metals with your acidic ferment. The cabbage pieces should be submerged below the surface of the salt brine under a weighted stone that might come with the crock, or with a plastic bag like a Ziploc bag filled with brine as a way of keeping the cabbage away from the oxygen at the surface of the salt brine. Because most spoilage mold requires oxygen to grow, if you cut off the access to that oxygen by keeping the cabbage pieces below the surface, you can decrease the possibility of spoilage. You'll want to keep the ferment that way stored for 3 to 6 weeks, depending on the temperature. Ideally, a cool temperature is going to produce the best product. Gas production might occur from the fermentative microbes, and depending on your setup, you might need to occasionally vent the container. Most of those traditional crocks are able to self-regulate. Once the fermentation is complete, the finished product can be consumed immediately or refrigerated. For long-term storage, the finished sauerkraut can also be canned or frozen. If you want to can it, the fact sheet available through Ohio Line also includes canning recommendations. A typical question we get about sauerkraut production is about fungal growth on the surface of the ferment. As I mentioned, reducing the exposure to oxygen by keeping the product submerged will help to control this. Additionally, you will sometimes get a scum of yeast that forms on the surface, which can be scraped off. But it's better to remove this growth quickly when you see it form so that it doesn't ruin the product. Okay, transitioning now into vinegar. You may have noticed that there are a lot of different kinds of vinegar out there. There's apple cider vinegar and red wine vinegar and balsamic vinegar and malt vinegar and distilled white vinegar. The different varieties result from whatever the starting product was. So apple cider vinegar comes from apple cider and malt vinegar comes from beer, and so on. The basic process for making vinegar is as follows. A non-fermented product like grape juice, wort, which is what you start with for beer, or apple juice, is fermented by yeast to produce ethanol and turn those products into wine, beer, or hard cider. Then a second fermentation by bacteria converts the ethanol into acetic acid or vinegar. So wine becomes balsamic or sherry vinegar, for example. To get distilled white vinegar, a distillation step occurs after this fermentation to remove a lot of the color and product-specific flavors. We're going to focus on just the vinegar fermentation. So this is a simple process that can be set up quickly during a demo or a class because you're already starting with an alcoholic product. That also provides some control over food safety because it will be very difficult for pathogens to survive within that environment. So if you're going to do this, you can select hard cider or wine or beer for your vinegar fermentation. The different products will give you a different sensory profile in the finished product. Just be careful that your wine, if you're choosing wine, doesn't contain sulfites, which are designed as a preservative, but they'll also inhibit the acetobacter fermentation. In contrast, if you were going to start the fermentation from a raw beverage, I suggest pasteurizing the product and then pitching the yeast. Pitching here means to add a starter culture. So similarly, if you're starting from an alcoholic product, I recommend that you add the vinegar starter as well, which can be obtained from a brew shop or online, or if you have a friend who makes vinegar. So for instance, I make vinegar, and if you need some starter, I can provide you with that. So the vinegar starter culture is sometimes called the vinegar mother or mother of vinegar. Some people will obtain their mother from a commercial product that's raw, so it hasn't been pasteurized, and they'll try and recover the mother from that product. Others will use wild fermentations where they rely on environmental contamination with acetobacter to carry on their fermentation. But in both of these options, while they're feasible, it increases the probability of a fermentation failure. So once the mother's been added, you can cover the ferment and store it for 4 to 8 weeks. In the containers shown here, they're covered with clean cheesecloth or coffee filters and a band. So your ferment will start to smell strongly of vinegar, so I suggest you be careful where you want to store that in your home for this month or two. When your fermentation is complete, strain off the mother of vinegar using a filter and a screen. You can then keep the mother and add it either directly into another batch to start a new round of vinegar production, or store it in your pantry in a little bit of the finished product for future use. With your finished ferment, you'll want to pasteurize it to inactivate any remaining mother, and then you can hot fill it or can it. You'll want to pasteurize it by heating to at least 180 degrees Fahrenheit for 5 minutes. So we have fact sheets also available on Ohio Line regarding the addition of flavoring to vinegar after fermentation as another popular trend. So to summarize, here are some of the key food safety parameters for fermented vegetables, but note that they vary depending on the product. First, as always, sanitation and hygiene are important when handling food. Since these products aren't necessarily heat treated, this becomes even more important. When possible, do pasteurize the ingredients, but this is only the case in products where you're adding the starter culture like vinegar. Don't do this if you're making sauerkraut because the fermentative bacteria are present on the cabbage itself. So if you heat the cabbage, you will kill the bacteria too. When possible, pitch the starter culture. So this works in the vinegar example, and it increases the likelihood that your fermentation will succeed since you're starting with a high level of the desired bacteria. For sauerkraut, be sure to add the recommended amount of salt. Salt inhibits pathogen growth, and so it will select for the outgrowth of the desired fermentative bacteria. And finally, don't use metal containers which can leach heavy metals into your high acid ferment. Feel free to direct any follow-up questions you might have my way. For your reference, ingredients, we currently have fact sheets from the food preservation team on Ohio line that address pickle and sauerkraut fermentation, and a fact sheet on flavoring vinegar. We also have fact sheets on kimchi and vinegar production in development.